Hello everyone. Today we will be looking at the last of this series in our chapter 1 on sampling and data. Here we are going to be looking more in depth of what is the data, kinds of different kinds of data like qualitative, quantitative, how do we display data in different forms. So all those things we would be looking in this video. Before we start on that, I am going to do a little recap of the things we have covered earlier. The first thing is that what is statistics? Now remember statistics, it is the art and science of learning from data, which means looking at a research problem you have, how would you collect the data for that research you are studying, then clean up the data, then analyze, interpret, and finally present your analysis to the appropriate audience. Examples of statistics is like average amount of TV which has been watched per day, or it can be the percentage of people who are concerned about global warming, or the median height of a woman in college, range of hand spans for college statistics students. Then we also looked at some of the key terms which are used a lot in statistics. Those key terms are very, very important for us, by the way. Like first key term is population. So if you are looking at a research problem, so you like to know what are all the in all these subjects or the entities involved in that population. For example, if I want to study all the left-handed students at APSU, so that means I would look at every student over there. Now that student can be from say a business major, or it can be a biology or a sociology major, or a mathematics or a statistics major. But we're looking at every possible student at APSU. So that constitutes the population. Now suppose if I want to study all the students, all the left-handed students, it may or may not be possible because there are some students who are outside the country. They are serving the country. So those kind of scenarios, what we do is we take a handful of people from the big population of APSU, and then we like to study that and make analysis from that for the whole population. So sample, as you can see, suppose this whole little circle represents all APSU students who are left-handed. And then if I want to just take a handful of them, I just randomly pick them up like this. Suppose all these red dots, I pick them up and I gather them together and put them in this little sample, say here, sample 2. Okay, so these are all the students who have randomly picked up, and they are the ones representing the red dots. Okay, or there can be some who have been picked up and written down on the other side of this population, which we say simply sample here. So that's one, another kind of a sample. So sample, just remember, is nothing but a subset of a population or a part of the big population. Then let's look at one example. So suppose we would like to predict the outcome of the 2010 elections in California. What was done was an exit poll was taken out of the whole 9.5 million people who voted in that elections. And the exit poll had taken a sample of 3,889 of those people. So what would define the population for this exit poll would be 9.5 million people. But what would be the sample? The sample would be those 3,889 people who had voted in these elections in California. Then the other parameters we have also talked about earlier is the term also is called a parameter. That is called the numerical summary, which we apply on a population. For example, we would like to look at all the proportion of all teenagers in United States who have smoked in the last month. So remember, the P of the parameter goes with the P of the population. So any numerical summary of population, guys, will be called a parameter. On the other hand, if you're looking at samples, so if you're taking a handful of sample from the whole population, so if you look at the numerical summary of a sample, that is called statistics. And look at the fact is that the statistics S kind of rhymes with the samples S. Okay, so let's look at an example. It's the proportion of teenagers who have smoked in the last month out of a sample of 200 randomly selected teenagers in the United States. Some other key terms is variable. Now, variable is simply a characteristic of every subject involved in a population or sample. For example, if I would, as we just started with the example of all left-handed students at APSU. So what is the characteristic of all this main thing which we're looking in that population is the left-handed students. So that is the variable. It is a common characteristic of interest we are looking at in a given population or a sample. We always denote a capital letter by, a variable by a capital letter. It can be capital X, capital Y, Z, A, B, C, D, just name it and you are there. Okay, now there are two kinds of variables. One is the numerical variable and the other is the categorical variable, which is basically the non-numerical variable. Okay, let's look at numerical variables. As the name suggests, these are the values which are taken by the variable and the numerical values. For example, it can be like weight in pounds, time in hours, okay? Or we can also look at the, suppose X is the number of points earned by one mathematics student at the end of a term, then X is a numerical variable. In a very simple form, numerical variable simply means the value to the numerical variable is in terms of numbers. Now, let's look at categorical. Categorical, as I said, it's non-numerical. So here they're going to place the person or a thing into a category. For example, if you're going to look at a person's party affiliation, then what are the possible choices for that variable? It can be either Republican, Democrat, or Independent. So those are two main categories of a variable, numerical or categorical. Okay, now the most important things in statistics comes into play. Measures of data. Remember, we are inundated with data all the time. Everything we can get hands of, there's numbers and numbers and numbers. Now these data, they can be numbers also, they can be words too. So data is the actual value. That's how a statistician would define as the actual value of a variable. Now they can be numbers or they can be words. If we use the word data, it means a single value. Now this data can come for a population or it can come from a sample. And how do we represent data values? We represent them as small letters like small x, small y, z, a, b, whatever you want. Now these data further fall into two categories: qualitative, quantitative. Now as the name quantitative suggests, it's a quantity, it's like numbers. Qualitative is non-quantitative, that means non-numbers. So now let's go and look deeper into these qualitative and quantitative data. We begin with qualitative data. Now, how does this happen? It happens as a result of categorizing or describing the attribute of a population or sample. Now, they are generally described by words or letters. So when you think of a qualitative data, this is not numbers. It's the most easy way to remember. No numbers involved. For example, color or hair color, type of blood, ethnic group, car a person drives, a street a person lives. These are all examples of qualitative data. Now they are much more simple. So anything which is not numbers and it describes attribute of a population or sample is qualitative data. The next one we have is the quantitative data. Now quantitative data means numbers. That's the best way to remember. Quantity, numbers. Now they are the result of counting or measuring attributes of a population or sample, remember. Okay, for example, amount of money, pulse rate, height of a person, weight of a certain object, number of people living in a town, number of students who take statistics. They're all examples of quantitative data. Now further, we can divide this quantitative data into a discrete or continuous. Now discrete data. So when we talk of discrete data, it is the simplest way to look at it is you can count like 1, 2, 3, 4. That's something which you can count easily. These are the data, they can take certain numerical values. Now, for example, how would we look, say, is this data a discrete data? For example, I would like to count the number of phone calls one receives in each day of the week. What are the values of phone calls? You can have 0, 1, 2, 3. Sometimes it's definitely going to be more than 3. So, but the way we're saying number of phone calls for each day of the week, there's a possibility that you can have more than 50 calls also. What is continuous data now? Continuous data in simple form means the values of the data which are in a range. Okay. For example, if you want to measure the weight of a backpack. Now, for a weight of a backpack of a school-going child, that weight can be changing. So it's some of the same class. Somebody might have, say, say 2 pounds. Somebody might have half a pound. Somebody might have 5 pounds. It all varies over here. So if you want to look at the weight, so when you see the word weight, you see the word heights, or you see the word time, those are called continuous data. Now, on the other hand, if I were say, if my friend and I are carrying backpacks with books to school, then the number of books in that backpack would form a discrete data, whereas the weight of the backpacks would form a continuous data. So the best way to remember a continuous data is like in terms of weight, height, time. Now, let's go ahead and do some practice problems here. We would like to identify the variable type as either categorical or quantitative. Now, when I say the word categorical, it also means qualitative. You can think of that way also. Now, if I have a quantitative variable, can it be discrete or continuous? So let's look at marital status. Clearly, it's a categorical variable. Number of siblings in a family. Number. Straight away, it's a quantitative. Okay, now if it is quantitative and I can easily count down the numbers, it means it is discrete. Number of cans on the shelf in a grocery store. Clearly quantitative. So I'm going to make my life simple. I'm going to write QD. Okay, that means quantitative, discrete. Now, length of time to take a test. Now, remember, depends upon individual to individual. Some might take 10 minutes. Somebody might take 10.25 minutes. So it's like a range of values you can take a time to take a test. So this is quantitative, definitely, but it is continuous. So I'm going to write this as QC. Your dog's weight. Clearly, it is quantitative and continuous. Speed of the train. Now, speed. Now, remember, when we are driving, think of this, when we drive, we're not going to have a constant speed. It's going to vary from minute to minute or time, seconds to seconds. So, the speed of the train is the same scenario. It is quantitative, continuous. So, now we have learned about what is a data, kinds of data, quantitative and qualitative. And now we're going to look at how can we display that qualitative data and how we can display it. Now, graphs are very helpful in displaying a data and understanding the data too. So if we are looking at qualitative data, the two graphs which help us to display it are pie charts and bar graphs. Now, when we look at pie charts, in a pie chart, The categories of the data, they're represented by wedges in a circle. And they're proportional in size to the percent of individuals in each of these categories. Now, this pie chart we have over here is representing a class of mine, and I counted how many students, how many females and males were there in that class. So suppose roughly there were 100 students, making my life simple, guys, by the way, and I found that the number of females, which is being represented by blue, so I had roughly around 60% were females, or so 60 students were females, and the males were the rest of the students. There were 40 in my class. So that's how you can represent a categorical variable. Now let's look at bar graphs. Now a bar graph is very much helpful when we want to compare the relative sizes of the categories. Now when you want to compare, then we cannot use pie chart at all. Remember that. Also, it cannot be used if the percentages which are added to less than 100%. That's also one more thing to write. Okay. Now, why I'm talking of this one, it over here is basically representing the pie chart. So when I say we cannot use a pie chart, first of all, I'm just repeating it again. A pie chart cannot be used if you're comparing the relative sizes. Also, if we add up all the categories and the percentages of all these categories is less than 100%, we cannot have a pie chart. So in a bar graph, suppose, now let's look at an example over here. Now this bar graph is representing it's a comparative study of different kind of student body in a institution, say, in a school or university, college, whatever you want. So so one of the the research which looked at how many students were under the age of 25. They say 61% of the students were under the age of 25, 48.6 were wanting to transfer to another university or a college. There were around full-time students, 49%, and all the students who were present were 100%. Okay. Now, some other ways to represent the data are called frequency and frequency tables. Now, frequency means number of times a value of the data occurs. Now, a relative frequency, it is the ratio of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. So, relative frequency is like a fraction or a proportion. We're going to do an example which will explain what I'm saying over here. So, just hold on for a second. Now, if you want to find the relative frequencies, what we do is we look at how many times a certain category was happening, and we divide it by the total number of the all the, say, subjects or entities which were present in that, say, sample or population. Now, relative frequencies can be written in terms of fractions, percents, or decimals. So this is just a little theoretical background. We are going to look at an example to explain what a frequency in a frequency table means, which will make it much more easier to understand. Now, let's look at, suppose there were 20 students in a sample, and these 20 students were asked how many hours they worked per day. Their responses were, somebody said, I worked for 5 hours, 6, 3, 2, 7, 5. Now, there's going to be repetitions too, because the question is how many hours you're working, and 20 students were asked. So what is done is we have all these 20 numbers, and we create a little table. In the first column of the table, we write down the data value here is the number of hours. We look at the data which was given to us by these 20 students, look at which is the minimum and which is the highest. So we find 2 was the minimum, and we're going around, we find, 7 was the highest. So we write this down, 2, 3, 4, 5, 6, 7. Frequency. Frequency is how many times these different values appeared, or the number of hours which a student was studying, or worked per day. So frequency is, so 2 was here 3 times. So 2, 2, and another 2. So frequency is 3. For 3 hours they worked was 5. Similarly for 4 was 3, 5, 6, and stuff like that. Now, relative frequency. Relative frequency means you add up all the values in the frequency. Now that is going to be 20. And it is a proportion of the data value which is being represented by 2 in relation to the total number of values. So it was the relative frequency would be 3 divided by 20 for the data value, which is number of hours worked per day by a student. If suppose a student worked 3 hours in a day, then the total number of students who answered was 5. The relative frequency would be 5 over 20. Similarly, if I pick up the, say, 5 hours was worked by some of the students in the sample set, and how many students who actually worked 5 hours? There were 6 of them. So what is the relative frequency? 6 divided by 20. And similarly, you can look at for all the rest of the data values. Now, where it is being used? Frequency table is very much used in conjunction with the categorical variables. What is a frequency table? It's a listing of possible values for a variable together with the number of observations for each value. And then we have something, because remember we also have proportions and percentages. And as I said earlier in my slide, that if you want to represent relative frequencies, we can write it as fractions, percents, or decimals. And that's why we're going to look at what is meant by percentages. And in order to find percentages, we need something called proportions. What is a proportion? It is the number of observations which fall in a certain category divided by the total number of the observations. So this is what a proportion is. And percentages are nothing but proportion times 100%. And as we just said earlier, that these proportions and percentages are also called relative frequencies. Now, there's something also called modal. Modal means, category means the category which has the highest frequency. So these are all terminologies and concepts for this chapter. Now we're going to look at an example which will help us explain what we have just learned, that how do you find proportion, how do you write a relative frequency table, and scenarios like that. Now, this problem says a stockbroker has been following different stocks over the last month and has recorded whether a stock is going up, down, or has remained the same in value. So these are the results. Now, I could have written it like that in the form of a, columns, but just to save space, I have written like this. So the first column basically is my first row here. So this basically is performance of stocks. Just to save space, guys, I have written in this little, in a more horizontal form. And this second column represents the count. Okay, so you have up, same, and down. And this is 21, 7, and 12. The first question is, what is the variable of interest? In other words, these data values which has been given to us is that there are 21 stocks which went up, 7 remained the same, and 12 actually went down in value. So the variable of interest over here is the performance of these stocks, because that's what we're looking at. This basically gives us what are we actually looking in this example. So the variable is the characteristic of the population or the sample we're looking at. Now this is a scenario of a stockbroker who's looking at how the stock is doing over a period or over the last month. So the variable of interest, remember, is the performance of stock. Now, what type of variable? Now, remember, we have two variable categories. It is the numerical or the categorical. So clearly, the performance of the stock either can go up, down, or remain the same. So this is a categorical variable. Okay, now we'd like to write down the relative frequencies. In other words, what we're going to do is we're going to create another column over here and write this as relative frequency. In order to do that, what we're going to do is we're going to add up all the number terms of the frequency or the count. So 21 and 7 is 28. 28 and 12 is 40. So the total is 40. And what is the relative frequency for the upstock performance? It is 21 over 40. For the same is 7 over 40. And the last one down is 12 over 40. Now it says what percentage of the stocks remain the same? That means this. So that means it's going to be 7 over 40 times 100%. So this equals 17.5%. Says which category of performance of stocks represents the mode? Now remember, mode means the one which has the highest value. And that answer is up. Okay. Now let's go to the next problem. Here, what we see is a nurse is measuring the blood pressure of every person who visited her clinic. Following is a relative frequency histogram for the systolic blood pressure readings for those people aged 25 to 40. We will use this histogram to answer the following questions. These blood pressures readings were given to the nearest whole number. So here is on the x-axis is the systolic blood pressure of these persons who visited the nurse clinic, and this is the relative frequency values. So that means if the systolic blood pressure was between 100 and 110, 0.15 is the relative frequency. So 0.15 or 15% of all the persons who visited her clinic had a systolic blood pressure between 100 and 110. So we can say this is 0.15. You can write down all the values. Between 110 and 120 was 0.35. 120 to 130 is 0.25. Then 130 to 140 is again 0.15. That's relative frequencies I'm writing, guys. Remember, relative frequency can be written as a fraction, can be written as decimal, or it can be also written as percentages. Then 140 to 150 is roughly 0.110, and 150 to 160 is 0.05. Okay, so let's look at the first problem. Approximately what percentage of the people aged 25 to 40 had a systolic blood pressure reading of at least 110 but less than 120? So in other words, we are looking at this tall little rectangle. Okay, so which is equal to let me use a different color here. That's 0.35. Now the question says what percentage. Remember, we are giving it in decimal, so we have to change it into percentage. So the answer would be 0.35 times 100%. That's 35%. Okay, next problem. Approximately what percentage of people aged 25 to 40 had a systolic blood pressure reading less than 120? That means not only including this tall little rectangle representing 0.35, but also now it's going to include the 100 to 110, because that's what the graph is giving. So basically everything which I'm highlighting with this little green lines, that's basically going to be included in this problem of reading of blood pressure which is less than 120. So it's 0.15 plus 0.35, which is 0.5. So 0.5 times 100%, so it is basically 50%. Okay, now let's look at another problem. A nurse measured this, I'm just repeating the same problem. In this one, a nurse measures the blood pressure of every person who visited a clinic, and she created a relative frequency histogram. And now this is one of the questions is being asked. It says, given that 200 people were aged between 25 and 40, so basically this all is representing all the 200 people. We would like to know how many had a systolic blood pressure reading less than 130. So before we can do the number of people, what we have to do is write down how many is in the relative. So 130 basically now means all the values of the relative frequency from 100 to 130. So that means anything you see over here, which is highlighted this with black lines, that's going to be included. So that gives us the relative frequency of people who had a reading less than 130. So remember, the first one was 0.15. Then the second largest, basically the second rectangle here is 0.35, and then other one was 0.25. So when we do the math here, this basically 0.75 or 75% of the people whose blood pressure was taken by the nurse actually had a systolic blood pressure reading of less than 130. Now that's 75% of every person whose reading was taken. Now what we are also given is that there were actually 200 people. So what we have to do, the number of people would be now basically 75% of this 200. So 75% of 200. What are we going to get, guys, the answer to be? 150. In other words, how do you do? You say 75 over 100 times 200. That's what you do. So the answer is 150. Okay. Now what we are going to look at are some other topics for you to know in statistics. These are things which we basically are actually used a lot in terms of research. Doesn't matter if you are in the field of biology or geography or sociology or statistics, you will be doing these things as kind of projects or some research or some lab work. Okay, so let's talk about those things. One is called observational study, and the other is called a designed experiment. So what's an observational study? Observational study is simply, the researchers are simply observing and reporting the attributes and take some measurements and the measurements which are taken. Now it can just reveal some association between the variables, but not the cause of it. For example, if a survey was done of 10,000 people and they were asked how much they smoke and their exercise habits. So basically, it's a very observational study. Just say, okay, hey, do you smoke now? Do you exercise? Yes or no? So it's just an observation and the report of the measurements taken. Okay, let's look at a designed experiment. In a designed experiment, researchers are adjusting they adjust imposed factors, observe and report the attributes and the measurements which were taken. Now, they can reveal some causation between the variables. For example, if we would like to know the effect of cigarette smoking and exercise. Okay, in this one, the first, if you're looking at the cigarette smoking with the effects to exercise, the first question was taking, I just randomly asked some of those 10,000 people, hey, do you smoke or exercise? So that's simply observational. But when it comes to design is that because you want to see, does cigarette smoking has an effect on the ability to exercise? That's what they really want to go. So what they're going to do is they will create some kind of conditions and subject these randomly chosen people to some form of a condition. For example, in this problem, what they did was they subjected 10,000 randomly chosen people, some of them, okay, not everyone, some chosen people were given a strict 90-day exercise. Then also they randomly assigned to each one of the 4 equally sized. So that's what they did. They divided this 10,000 into 4 parts. Okay, and they said, okay, one of them, the group was, you had these were the mandatory smoking rule. One of the 4 groups, they were non-smokers. They said, you're not going to smoke. One group was allowed 3 cigarettes per day. The other was allowed 10 cigarettes per day. And the last group was allowed 20 cigarettes per day. So here what they're doing is, as they really want to know the cigarette smoking affect the ability to exercise, so they had those 10,000 people. They divided into 4 groups. and they had to do 90-day exercise, but this was the specific conditions. You will not smoke, or you can have 3 cigarettes per day, or 10 cigarettes, or 20 cigarettes, and then they will do their observations and show their reports. Okay, another thing which happens in lot in statistics is census versus sampling. Okay, census are thorough and time consuming. As we all know, right now we are having this 2020 census going on. So here, because you like to know about the whole population of United States of America, I'm talking about the 2020 census of US. Now, in order to collect information from every citizen present in the United States, it's going to take a lot of time. So that's why it's done every 10 years. So on the other hand, if you really want to do you want to look at some of the results or things going on, so what you do is you do a sampling. And when you take a handful of people and you want to do some research and take some, make some analysis out of it, you randomly pick, people in your research study, and then, you look at how the effects and the behaviors are being done there. So in this one, we have a simple random sample. Now here's little stats over here. A simple random sample of n distinct items from a large population is chosen in such a way that each set of these n items is equally likely to be chosen. This type of sampling is done without replacement. So let me talk about the simple random sample here and give you an example of what I mean here is like. Suppose I had a population of 4 people. Okay. Now, if I have a population of 4 people, so it's Al, Bo, Carmine, and Debbie, and they're enrolled in a class, that's only the students in that, I would like to say how many different committees can be formed from this group. So the number of committees which can be formed is, from all these 4 students in the class, it can be one committee, one committee of all 4 people, or I can have 4 committees of 1 person each, 4 committees, like every committee has only 1 person each, or I can have, say, committee of 2 people each. So I can have, say, committee with 2 people. Now, or a committee with 3 people. So how many number committees I can have, So for example, let's look at the next question. It says, how can we randomly choose 2 students to form a committee? So in other words, if I want to form a committee with 2 people, and remember there's no replacement. Once you go on a committee, you're done. So a committee with 2 people. So how many people we have is 4 of them, A, B, C, and D. So we can write so we have A, B, C, and D. So if I'm going to form 2 people committees, so the number of committees I can have here. So I can either have Al and Bo together, and then I can have Al and Bo, or I can have Al and Carmine, or Al and, Debbie, or I can have Bo and Carmine, Bo and Debbie, or I can have a number of all possible committees of 2 people. That's what we're trying to do here now. So one is Carmine and Debbie. So the number of committees of 2 people are 6. 1, 2, 3, 4, 5, 6. Okay, so that's just a simple combinatorics to give you an idea how these will be, what we had just talked about, simple random sample without replacement. You will do these kind of problems later on, but I just wanted to give you an idea of what comes here. And lastly is computers. Now, we all know about computers. How do we use it? How ways we can use computers in statistics? Now, suppose if you want to do samples, there are certain scenarios we cannot take samples. So, like suppose if you would like to see the effect of, some nuclear reactions. Now, you do not want that to be really experimenting. You can simulate those kind of experiments. Now, in order to do those simulations, what we do is use computers to actually see what will happen if, some explosion happens and there is some nuclear, stuff involved. So what we can do is simulate a random phenomena And this we can simulate them using our computers, and there are many softwares which can help us to do that, like Excel, Minitab, TI-8384 calculators, R, Python. There are a lot of softwares. So what we do is we simulate those random phenomena instead of actually creating an experiment there. And then once we do the simulation, we run statistical analysis and make charts and graphs, and then figure out the scenarios of what can happen. Another scenario could also be, in this example, would be, so we would like to see how, if an earthquake happens, what are the aftermaths of the earthquake, the destruction and the loss in terms of, these buildings or people. All those things really plays a lot. So in those scenarios, we do not want to really have that to happen, but if we can simulate certain scenarios using our computers, we are, so that if these kind of natural disasters happen, we are prepared of what to do to protect our community and our people. Thank you.